Hello and welcome to video number 8 in this series, and in this video I'm going to continue our exploration of exponents by looking at rational exponents and roots. If we raise a real number a to the power 1 over n, where n is an integer greater than 1, then we obtain the principal nth root of a, which we write with a radical sign and a small n here. If a is positive, then the principal nth root of a is the real number b, such that b raised to the power n is equal to a. So, for example, the principal third root of 8 is 2, because 2 to the power 3 is 8. And similarly, the principal second root of 16, and this is just called the square root, and so we often just omit the 2 when we're dealing with square roots. The square root of 16, the principal square root of 16 is 4, because 4 squared equals 16. Now we also know that minus 4 is a square root of 16, because minus 4 squared is 16. But minus 4 is not the principal square root. Plus 4 is the principal square root. So that's the case when a is positive. When a is negative, it depends whether n is even or odd, whether we even have a solution. So if n is odd, then we're okay. We do have a solution, and b is the real number, this time a negative real number, such that b to the n is equal to a. So to give you an example of a being negative, let's take the principal third root of minus 8. So that's minus 2, because minus 2 cubed is minus 8. If a is negative though, and n is even, then the principal nth root of a is not a real number. So an example here would be if I tried to take the square root of minus 4, then there is no such real number that I could square to get minus 4. And the only other thing that we need to worry about here is I haven't really talked about when a is equal to 0. But that's easy because the principal nth root of 0 is just 0. So let's just go through a few more examples. Let's do the principal third root of 27. So that's 3, because 3 cubed is equal to 27. Let's do the principal fifth root of minus 32. So we can do that because 5 is an odd number, and we've got an odd base here. And that comes to minus 2, because minus 2 to the power 5 is equal to minus 32. And then let's throw a fraction in here. Let's do the principal fourth root of 1 over 81. So that's going to be 1 over 3, because 1 over 3 to the power 4 is the same as 1 over 3 to the 4, which is 1 over 81. And here, minus 1/3 is the fourth root of 1 over 81, but it's not the principal fourth root. So let's expand this idea with exponents of the form 1 over n, and let's consider what it means to have an exponent that looks like this, m over n. So what does that mean? So we could either think of this as the principal nth root of a to the power m. That's one way to think about it. And the other way is to think about the nth principal root of a to the m. So both ways are legitimate ways to think about this, but in practice it's generally easier to work with this form than this form. So I'll just run through a few examples to illustrate that. Let's do an easy example first. Let's do 8 to the 2 over 3. So let's think about this form first. We're going to have the third principal root of 8, and then we're going to raise that to the power 2. So the third principal root, or the principal third root of 8 is 2, and 2 squared is 4. If we think about it the other way round, we would have the principal third root of 8 squared. And 8 squared is 64, and the third root of 64 is 4. So the arithmetic involved here is a little bit more complicated than here, because here we had to take the principal third root of 64, and I know that that's 4 because I know that 4 cubed is 64, but it's a little, there wasn't anything difficult to do here. The principal third root of 8 is 2, and then 2 squared is 4. So this is easy, and this is a little more challenging. Let's do an example with a negative number in. So let's do minus 8 to the 2/3. And let's do the first method, because that's a little easier to work with. So that's going to be the principal third root of minus 8, and then we're going to square that. So that's actually also going to be 4, because the principal third root of minus 8 is minus 2. That was an example that we did over here. But minus 2 squared is just plus 4. So we end up actually with the same answer here. Let's do another example. Let's do 81, and let's do a negative fractional exponent. Let's do 81 to the minus 3/4. So let's just write down what that means first. So it's going to be well, actually, because I've got a negative exponent here, the first step I want to do is I just want to push the 81 into the denominator and make this positive. So it's the same as 1 over 81 to the 3/4 exponent. And then I can write down what this means. So it's the principal fourth root of 81 cubed. The fourth root of 81 is 3, and 3 cubed is 27. So this comes to 1 over 27. And then let's do one last example here. Let's do 9/16 to the 3 over 2 exponent. So let's write down what that means. So that's going to be the square root of 9/16 cubed. Square root of 9/16 is 3/4, and 3 cubed is 27, and 4 cubed is 64, so that's going to be 27/64. So that's working with numbers. We can apply the same ideas when we work with variables as well. So let's do a couple of examples with variables. Let's do 9x squared y to the 4. And then let's have a 3/2 power there. So let's think about what that is. So let's do the constant first. So we've got 9 to the 3/2. So that's the square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. We've got x squared to the 3/2. So when I've got an exponent and then I've got another exponent, I multiply them together. So 2 times 3/2 would just be 3. So I've got x cubed. And then y to the 4 to the 3/2. So multiply 4 by 3/2. And I'm going to have 6. And then let's do one more example. Let's do 1/64, and then x cubed, and then y to the -6, and then let's have that be raised to the power of 1/3. Let's deal with the constant first. It's got 1/64 to the 1/3 power, so that's the principal third root of 64, which is 4, and it's in the denominator. So I've got 4 in the denominator. And then I've got x cubed to the 1/3, so 3 times 1/3 is just 1, so I'll have x in the numerator. And then I've got y to the -6 to the 1/3. -6 times 1/3 is -2. So y to the -2 is the same as having y squared in the denominator. So pause the video here and see if you can work through the next two problems that I'll write up. And what you want to do is apply the ideas that we've been talking about here, particularly these last two, because the next two examples will be more like these two. And I want you to work through and simplify these two expressions. So for the first one, let's do 16. Gonna do that again with a different pen.
The color's good.
I know,
Yeah,
it's
drying out.
yeah. It's a shame. I like the orange.
One of those other ones good.
Oh, maybe that one will work. Yeah. Let's give it a go anyway. So for this first one, we're going to have 16, and then x to the half, and then y to the -2, and then 3/4. And then for the second one, let's do x to the -4, and then y squared, and we'll have -1/2. Actually, I'm going to add a little bit more to this. Let's divide this by 49 before we do the -1/2. So let's see how you did with these two examples. So let's deal with the constant first in the first one. So we've got 16 to the 3/4. So that's going to be the principal fourth root of 16, which is 2 cubed. So I have 8. And then we've got x to the half to the 3/4. So that's going to be x to the 3/8. And then we've got y to the -2 to the 3/4. So that's going to be y to the -3/2, which is the same as having x to the +3/2 in the denominator. Sorry, y to the 3/2 in the denominator. And then the second one, let's deal with the 49 in the denominator first. So we got 49 with a -1/2 exponent. So a 1/2 exponent means the square root. So the square root of 49 is 7. But the negative means I have to move that from the denominator into the numerator. So we'll actually have 7 in the numerator. And then we've got x to the -4 to the -1/2. -4 times -1/2 is +2. So that means x squared in the numerator. And then we've got y squared to the -1/2. 2 times -1/2 is -1. So we've got y in the denominator. So before we finish up this video, I'm just going to explore a notion called rationalizing the denominator. Because sometimes, not always, but sometimes, we're trying to end up with an answer at the end that doesn't have any roots in the denominator. And so I'm going to show you how to remove roots from a denominator if that's your desired outcome. So we'll start with just a very simple example, 1/√2. If I want to rationalize the denominator here, I need to multiply this √2 by something so that we can remove that root. And the number that works here is just multiply by another √2, because then √2 times √2 will be 2. And we've removed the root from the denominator. And to do that, we need to be multiplying by a fraction that's equivalent to 1. And so we just do √2 over √2. So now, if we multiply the numerators, we get √2. If we multiply the denominators, we get 2. For another example, let's do one that's similar but just a little bit more challenging. Let's do the principal third root of 2 in the denominator. So what do I need to multiply by to get rid of this? Well, if I multiply by the principal third root of 2 squared, then if I multiply these denominators, I'll be able to get rid of the root. And so I got to have in the numerator the same thing. So now when I multiply the numerators, I'll have the principal third root of, I'll just write 4 instead of 2 squared. And then in the denominator, I've got the principal third root of 2 and then the principal third root of 2 squared. So multiplying these together, I've got the principal third root of 2 cubed. And the principal third root of 2 cubed is just 2. So that's some examples just with numbers, and let's apply the same kind of idea with expressions that contain variables. So let's suppose I have this expression here, x over 2y, and the 1/3 power. Okay, which is fine as it is, but we do have a fractional exponent in the denominator here. So we have a root in the denominator. So if we want to rationalize the denominator here, what we need to do is multiply by So 2y, if we've got the 1/3 power, to get that up to a power of 1, we would need to have 2y to the 2/3 power. Because now these two multiplied together would just give us 2y. So we've got 2y to the 2/3. So it's easy enough to see what we've got in the denominator now. We've just got 2y. But what do we have in the numerator? So we've got x to the 1/3. We've got 2 to the 2/3, and we've got y to the 2/3. So let's think about what we would need to write here to have everything to the 1/3. So we've got 2 squared to the 1/3, so 4 to the 1/3 power. We've got x to the 1/3, and we've got y squared to the 1/3. So writing this using the radical notation, we'll have the principal third root of 4x y squared over 2y. So that's it for this video, and in the next video we're going to switch gears a little bit and start looking at polynomials.